And welcome to this video. I want to go over the principles of surfacing and how to get smooth, organic, um, almost lifelike surfaces like this with very little effort. It's worth pointing out that surfaces are not the end goal of modeling, but rather they're the means to the end. You never want to have your finished product be a surface, but rather the surface will deliver the organic results that you wish and create the solid from that organic geometry. So there are several ways to surface, and again, this is for smooth surfaces like if you think about a computer mouse, it doesn't really have too many straight edges, and it's made to be very ergonomic to hold on to. And so let's talk about some of the principles of making this infinitely thin reference surface. I want to start by making another part. And I'm going to make a simple sketch on my top plane. And notice that spline is probably a good place to start because splines can become very complex. Once I make any kind of a closed sketch, and of course the closed sketches have the shading in the middle on SolidWorks 2017 and up, I can go to my Surfaces tab, which if I don't have this tab, I simply right-click and select Surfaces. And one of my most simple commands as I rebuild my sketch is a filled surface. I simply take something enclosed and I can fill it with a surface. And then I hit OK, and I have a flat surface that fills whatever sketch that I've made. A likewise similar and simple way to generate surfaces, and I might even say perhaps more useful, is if I select a plane and sketch, I'll again use my complicated spline. Whatever profile that I wish to make, I simply run to my surfaces and say extruded surface. And I can specify a distance. And there I have an extruded surface. Again, producing whatever complex organic geometry that I wish to have. One of the tools given me, and this isn't necessarily only for a surface extrude, but something to play with if you find it useful, is the surface flatten feature. If I wish to make this perfectly flat, let's say that this is a piece of cloth or something like that, and I want to lay this cloth flat, there indeed is a way to do it within SolidWorks. I simply choose Surface Flatten, and I select the surface that I want to flatten. And then right here I can select an edge. And this, I'm going to tell SolidWorks this edge is going to stay stationary, and I'm going to flatten the surface off of this edge. And it creates a flattened preview tangent to the edge that I have selected. From here, as you can see, it generates a mesh, and I can adjust the accuracy of my mesh. I can go to a low mesh or a high accuracy mesh. Of course, the high accuracy is a little bit CPU heavy. And then I can hit my green check. And there I've generated the dimensions of my surface should I lay it flat. This is almost reminiscent of modeling something in sheet metal and is worth checking out if this is something that would fit your needs. It's especially useful when modeling something like a cloth. With that being said, I'll delete these two. Some of the other features that I have is I can even make a plane on this spline that's left over. By saying Features, Reference Geometry, Plane, and then I can choose this endpoint. And I can make some other profile on this plane. If I sketch on this plane, maybe I'll use a 3-point arc. And I can move the midpoint to be coincident to my origin. I can make this symmetrical by horizontal, perhaps vertical. would be a more appropriate choice, and give it a radius and maybe some other arbitrary finishing dimension. And if I rebuild, just like modeling in solids, I can come to surfaces and choose swept surface. These, of course, are not very useful examples. They're just examples to show how surfaces can be generated. Let's say I can make relatively complex surfaces pretty easily. So what are some of the advantages to surfacing then? And I should also point out that lofted surfaces work the same way as in solids, and we'll be doing an example of lofted surfaces very shortly. So what are some of the benefits? Well, the idea is if I were to make a computer mouse, I can, in fact, I will create a quick example. If I were to make a computer mouse through some other way, right, maybe lofting may be the best option. So if I sketch on the front plane and I make, a very basic computer mouse shape, I'm not going to work too hard on this at all. And then I make a second plane. Let's go with distance of something like 4 inches. Maybe to keep it proportional, we'll make it 2 inches. And I want to make this basic computer mouse shape. I'll end up square on one end. It's going to be a terrible computer mouse, but it's going to illustrate what I want to tell you. Features, loft, from here to here. Well, now that I've lofted, I've created all of these surfaces all at the same time, right? I've got 6 surfaces, 1, 2, 3, 4, 5, 6. And lofting, I have to make a ton of guide curves to make sure that every surface is the way that I want it all at the same time, simultaneously. And that can be very hard and very complicated to do. So, surfacing provides us an alternative to where I make this top surface, and then I make this side surface, and then I make this back surface. And by doing one at a time, I can fully control every surface to be exactly the way that I want, and no compromises. The other thing about lofting is sometimes profiles can be too complex to loft, right? A solid loft just can't keep up with the complexity. However, doing the exact same loft as a surface and then making it thick later will work. So surfacing allows us to run the same loft function in a more complex profile and be able to do it, whereas a solid surface just wouldn't be able to keep up. So let's run through an example. Let's say that I want to make a computer mouse that's completely well surfaced. I'll get on my, let's say my right plane, and I'll get normal to that and begin a sketch. So let's worry about only the top surface of a computer mouse and what it might look like. I'm going to begin by making, I'll say, a very wide, large arc. And we'll give this a radius of, say, 4 inches. And we'll give this a front to center length of, say, 2 inches. We'll make this not only vertical with our origin, but I think I'll also make this the tallest point of the mouse, which implies that my curvature at this point will be tangent to horizontal. Now I'll give the front end a height and make it something like 1/4 inch. And we'll say that this origin kind of represents the bottom of the mouse, or where the mouse is going to sit on the desk. Maybe we'll make this a little bit taller, maybe 0.4. Now from here, I'll choose a tighter profile. Again, will be tangent because we want the mouse to be smooth. And we'll make this perhaps a smaller mouse of 1.5, meant 1.5 over here. Now I'll make the back end maybe an inch. Oops. And we'll go 0.5, so we're a bit taller in the back. And that looks kind of like the profile of what a top mouse would look like if you looked at it directly from the side, which is what we're after. I'll make these vertical to shore up my construction line. Now with that, that probably looks good for what we're doing. So mouse end to end is going to be about 3, maybe 3.5 inches by the time we're done. This will be one of those small portable mice. So I'll end there and then get on my front plane and sketch another profile. This would be the profile of the mouse if we were looking at it directly from the front. So I'll create an arc and I'll say, what do I want the top of my mouse to look like if I'm looking at it from the front? Say the cord coming out of the front would come straight out of the screen. Make this tangent. We'll make these horizontal and make these arcs equal. And I'll make the top pierce. Well, actually, I will probably that's a pretty decent profile there. So how wide am I? I am I need to move my center downwards. So I think what I'll do is make it vertical and choose a radius. I'll have my radius be 3 inches. Now I am much more wide than I care to be, but that is okay because I am going to be using a certain surfacing tool that will get the surface of my mouse exactly the way that I want to. So to fully constrain, I'll give this a width of 3 inches. I'll rebuild my sketch, and from here, just like we do in solids, I will go to my surfaces, choose swept surface, and make this profile along this path. And then I have several options. I can do one side, another side, or both, and of course I want both. And that is the top end of my computer mouse. You can start to see what I'm getting at here. Now I'll choose my top plane and say, what do I want my mouse to look like from the top? I'll sketch on my top plane, and perhaps I'll start with a 3-point arc. Choose this point, and of course I can make this tangent to my surface. Maybe I'll just have a real brief curve and have the mouse go into a straight line. Of course, you're the engineer, and you can make it any way that you want to. Make this, say, a 1-inch radius. Now, how wide do I want my mouse to be overall? Well, perhaps I'll put a 3-point arc over here. And let's say I want my mouse to be 1.5 inches wide at its widest, or that'll make a 3-inch wide mouse overall. Well, our mouse is proportionally a little bit smaller, so I'll go with 1.25, and that's looking all right. And so again, I'll add a reference to make sure that this is tangent to vertical. That means any subsequent tangency I have will have to come in this way, which is what I want. And from here, we'll add in another arc, tangent. And now I'm going to probably put in a sharp edge right here. You may think, hey, I don't want to have a sharp edge on my mouse because it's not very comfortable to hold. But sharp edges are a little bit luxurious because we can add in a surface fillet or even a solid fillet whenever we progress. So we don't have to make everything completely tangent. The thing to look out for in surfacing is I don't want to have a fillet that will run into something that is tangent, whereas there's a sharp edge in another spot. The fillet won't work. It'll say something like cannot fillet lateral surfaces or something like that. So if you get that error, you're probably getting a sharp edge that's running into something that becomes smooth later on. Okay, so let's add some dimensions that will get this completely constrained. I'll turn that okay. And that kind of looks like a computer mouse from the top. I'll change this 0.85 though. It kind of moved on me. And that's a little bit better design intent. Okay, I am going to create a center line. And I'll create a sketch mirror. And I'll move these entities over this line. And now, of course, I'm not fully constrained. It looks like I'm not constrained in this area. So it looks like I've lost that dimension that I had placed it in. So we'll re-add that in. That looks like a mouse from the top, a small one. So from here, I want this surface to have this profile when viewed from the top. So to do that, I'm going to remove anything that is not a part of this profile. And that's an easy tool to have. It's called Trim Surface. So I go to my Surfaces tab, I choose Trim Surface, and it asks me for a tool. So I'm going to use this sketch as my trim tool. And then I can select what does and does not align with my surface. So I'm going to select, and I have the option to either keep or remove what I've selected, and I want to keep what I've selected. And so I'll click the green check, and there I've got my upper surface for my mouse. This mouse is, when I look at it, it's a little bit like not tall enough. So I'm going to go to my sweep and the luxurious surfaces and just in general parametric modeling is that I can begin to make some adjustments. So I'll take this radius and I'll make it something like 3 inches, which makes me substantially taller. Now if I rebuild, I have a completely new profile to work with. The other thing, perhaps I want the mouse to have a little bit of a taller back end. And so I can adjust my surface by simply saying something like 0.75. Maybe I'll make this 0.45. And if I get a rebuild error, it looks like I'm simply not referencing some aspect of my sketch on my surface trim. So I've lost a coincident. and some coincidence over here. That's not too bad. I'll simply re-add them in. And we're fully defined again. And I have the same case down here. And we're fully defined. So if I have any conflicts with sketches, I simply re-add the lost constraints in an update. Now I'll rebuild, and we have no more rebuild errors. So let's begin working on another surface. Let's go with the side of our mouse. This is a really fun one, and this will be a good example of a surface loft. So I'm going to start doing the side by making a path for my loft to follow. Not the profile, but the path. I've highlighted the side of my top surface, and I'm going to sketch in a 3D sketch and simply convert entities. So now I've got a sketch running along the side of my top surface. I'm going to do the same to create my bottom path, and I know that my top plane is going to be the very bottom of my mouse. That sounds paradoxical, I know. I'm going to sketch on my top plane, and I'll highlight all these parts of my surface and simply convert entities, which converts my 3D sketch onto my 2D surface. And that will be a good bottom for my mouse. And now I can make a few other profiles. And of course, when you start with a wireframe, I think this mouse looks a little bit tall. So I'll go back. The beauty of parametric modeling is I can always make changes. I'll make this dimension come back down to 1/4 inch after all. And I'll make this maybe 1/2 inch. And that seems a little bit more reasonable and computer mouse-like. Now I can make another sketch. I can go 2D on this right plane and simply make a line coming down. This will be my starting profile for my loft. And I can do the same ending profile by making another sketch on my right plane and going again from my known point to my known point. Finally, I can start worrying about what some of my intermediate profiles will look like when I make a loft. So notice my front plane aligns with, I do not align my front plane on these points, and these points would be a good place to loft from. So I can either sketch on my front plane or create a sketch that is parallel to my front plane and choose this point. Either way, I don't think it makes that big of a difference in our finished profile, so actually I'll just sketch on my front plane, and I'll make a 3-point arc. And I'll choose this edge and pierce. Oh, but it looks like my front plane goes on this edge, so I'll pierce, pierce. And now I can choose a radius, and mice are kind of concave usually on the edges to make it more comfortable to hold on to. So I'll choose a 1/2 inch radius. I don't think I can get away from it. I want to put another profile here for my loft. So I'll choose reference geometry, and I'll choose my front plane as a reference to be parallel to. And then I'll choose as my second reference this point, and I'm fully defined. So now I can sketch on this plane and make sort of a more shallow version of my profile so that I can progressively get deeper as I go down the mouse, which I think would be quite ergonomic. I make this have a radius of 1 inch, much more shallow. And that looks like it would be a pretty clean and smooth loft. Now I've got several options with lofting, just as I do with my surface. Oops, I don't want to delete this, I want to hide this. And I'll show one way to do it, surfaces, and I can run a lofted surface, and I can run through all of these profiles, and then add my paths. And now I've got my mouse completely filled in on the side. And you say, well, this wouldn't be very comfortable to have this sharp edge, and certainly we will be adding a fillet when we are all done along this edge, and that will make things a lot more smooth. The other option is I'll get rid of this surface. But there's always some options that I can make this my profile and this my profile, and I can add these in as paths. So if you ever get frustrated with the way that one turns out, notice we've got a slightly different profile and a slightly different surface, so you can always try to reverse. You can pass your profile and your profile your paths and see if that's something that you like better rather than trying to start over entirely. Okay, so with this mouse fully lofted, I can go through sketching the other side, but that's a lot of work and I'm kind of lazy. So instead I will do a mirror on this right plane. I can go to my features and choose mirror. Now mirroring a surface is a little bit nuanced because if I choose this feature to mirror, I just simply can't select it no matter what I do. So I'll choose faces. Well, I can't mirror this as a face either because really surfaces are not features, they're not faces, they're infinitely thin, almost references you can think of them as. And so I can somehow recognize them as a body. And I can click my green check and I've mirrored this surface. However, sometimes you will run into trouble and it will not mirror. And if that's the case, simply say Edit Feature and say Merge Solids or Knit Surfaces, whatever you want to do, and then it will mirror. So I will not do that at the moment. With that being said, we have several options to complete our mouse, and I want to go over all of them with you. The first thing that always frees us up in adding features and things is I've got 4 surfaces here. I want to make them into one surface because then I can add cool stuff like fillets. Right now I can try to add a fillet on this edge and it doesn't even recognize being able to make a fillet. So to sort of give us more options and more flexibility, once I have all my surfaces that I want, I'll add in a knit function. And that's when I knit my surfaces together. I take this surface, make them into one surface. So I'll knit my surface and I'll choose everything that I want to make one surface. I'll choose here, here, and here. It looks like I have 3 surfaces. I forgot this isn't 2 surfaces. And I'll merge entities. From here, I've knit these into one, and if I want to add a surface fillet, I now most certainly can. That's a very large fillet, but I can do it if I want to. I prefer to add my fillets as late in the game as possible, but that goes to show what knitting does. It makes it all into one and recognized into one. So now with this computer mouse, there's a few options that I can make this into a solid. One of the easiest ones is to choose this Thicken guy up here, and it is exactly how it sounds. I choose the surface that I want to thicken, and because we're all knit, we can make this thick. Now the preview shows us we're adding material to the outside, but if you're like me, you kind of think, well, I've dimensioned it with the outside dimensions, so I can convert my thickness over here to my inside dimension, or I can add that thickness onto both sides if I desire. I want to thicken the inside. And there we go. Now that I have a solid, I have validity on my features, such as extrude cut, which I could not make on a surface. I would have to use like a trim or something like that. Notice I don't necessarily like this thickness that has been added, and so extrude cut is probably a decent way because this thickness extends below my top plane. One of my options is I can sketch on the surface, and I can convert entities here and here and here, here, here. Essentially, I can even choose those faces. Oh, apparently I can't choose those faces, so I can just continue selecting these entities and once again convert entities, and there I've got a complete profile. Features, extruded cut, through all, and now we're flat again. So that's one simple way to restore the extra thickness that we don't want. Another thing that I can do, if I roll back, I can convert entities on here and here. I simply say sketch, 3D sketch, convert entities, and then go back to my surfaces and say filled surface, choose my sketch. Now I've made a bottom of this mouse, and then if I go to thicken, I'm probably going to error out, maybe not. Oh, I didn't error out, I just need to edit my feature, and oh, I even need to go back to my surface knit. I'll move this down, edit my surface knit to include this bottom surface, and now with all my surfaces knitted together, I've actually thickened so that I have a hollow shape. And I come down and I can cut extrude. Notice my cut extrude isn't valid because I'm already flat, so I can get rid of that if I wish. And my sketch doesn't reference anything correctly anymore. The other thing, if I want to make this mouse completely solid, I'll delete my thicken command. So now I'm back to just having a knit surface. I can edit my knit surface and say create solid. And now the whole thing is solid. So that's a way that you can fill up all of your surfaces if you want them to be absolutely, entirely, completely solid. So I'm going to leave this being solid. And I'm going to add, as I approach the end, I can add my fillets, or I think maybe there's a few things I want to do before I do that. That is adds just some of the visual details. If you were actually making this mouse, perhaps your best option would be to either thicken all the surfaces without this bottom surfaces we did, or since I've made the whole thing solid, I can add in a shell feature. Perhaps I can shell this to a thickness of 0.1 inches. Of course, I have a value larger than my medium radius, but it seems like it turned out okay. So anyways, now that I've got this worked out, let me just sketch on this bottom face or my top plane. Either one will work. So I think I'm going to convert entities over here. It looks like I am unable to convert entities. There we go. And as you can tell, I'm going to be making that little slot that runs through the middle of the mouse. Now I can dimension this line to be off of our center, say 10 thou. I'll make a trim, and then I'll make a line that terminates vertical to the origin. Now I simply need a distance for this slot to last. Let's go with, I should say 1 inch and see how far we go. That seems like a reasonable amount. Now I can make a center line that goes from my origin to this last point, and I can mirror. SolidWorks seems like it's a little bit stubborn box selecting there, so I'll clear my, well, I guess I cleared everything there, so I will re-add this line, and I'll mirror about my construction line. And I've created a closed surface that I can now extrude cut through all in the other direction. That's starting to look very mouse-like. On my front plane, I won't, since this is only an example, I won't spend a lot of time making this amazingly brilliant or anything, because I'm sure we've got better things to do with this time. I'll create a sketch and get normal to this plane. And this can be a little bit tricky because scrolly wheels aren't, their midpoint is not on the surface, but rather below the surface. In fact, yeah, in fact, I think I will sketch my right plane. And I'll make a scrolly wheel. Although the wheel axis doesn't really have any relation to this edge, it looks like it's a pretty good height and size if I make it coincident on that edge. There we go. So I'll make this a 1/2 inch. And just as a lateral locator, 1.5 looks pretty good. So I'll extrude this mid-plane. And a scrolly wheel is probably 1/4 inch wide at the most-ish. Even that's kind of wide. Go an 1/8 inch. And that looks pretty reasonable there. So again, this is simply a cosmetic touch. In some of my other mice, I've actually extruded this little surface out with a cut, but again, I don't want to waste time on small details that aren't necessary for the core of what I'm trying to go through here. So I can add a radius in. It looks like there's a little bit of an error, so I'll do a face fillet instead. And there's still a bit of an error. So I'm not even going to worry about it because I don't want to go through cleaning this up when my core message here is surfacing. And so just simply put some finishing touches on the mouse. We'll add in our fillet. It's quite a complex fillet. And that looks pretty good. So I'll edit this fillet and simply put the same size on the bottom, and that should be conducive to not catching on things when you slide the mouse around. And it doesn't seem to like that. So I will X out of this fillet and simply make a different one of a different radius. And a 50 thou fillet looks very reasonable. So that looks to be a somewhat acceptable computer mouse. Maybe it's a little bit wide for my taste, but nonetheless it turned out decently well. Again, you can clean up this wheel any way that you want to. I'll probably just clean this up for the thumbnail. So I hope this video was quite helpful for surfacing techniques, and I hope this was a decent segue, if you've never surfaced before, into many of the possibilities that you can have when you create surfaces. Again, the advantage is being able to create this top surface all by itself was so much easier and able to make it so much more organic and detailed than if we were to do a loft with solids. So there's some of the virtues of surfacing. Again, I hope you've enjoyed this, and I'll catch you in the next video.